So in this example, I have the integral of 2x squared times x to the third minus 5 to the 6th dx. So I'm going to use substitution. So in the process of substitution, what I want to do is I want to find a term that I could set to u. And what I want to have happen is when I take the derivative of u, so meaning taking the derivative of u would be du, I want the derivative of this term to be able to substitute out the rest of the term. And I know that sounds a little confusing of what we're trying to get done here, but I want to be able to remove everything out of this integral here and pretty much just change it in terms of u. And when I change it in terms of u, I want to be able to integrate that u. So I'm noticing right now I have x to the third minus 5 to the 6th. I'm going to set this term as my u for two reasons. Reason number one, I have all of this statement being raised to the 6th. That's really hard to manage the integral portion. Like if I try to integrate that, like I can't do it. So I'm going to try that as a u. Also, the second reason being, if I take the derivative of this term, look what I get. So the derivative of this is going to be 3x to the second, minus 5 is a constant, and then that's dx. Look what happens. X squared dx, x squared dx. So I pretty much am able to substitute out x squared dx for this du. Now I know I have this 3 here, which we'll deal with in a second, but I'm hoping that you're kind of seeing like, okay, I could see this is going to be pulled out of now the problem and replaced with du with this 3 here that we're going to have to worry about. And then I have this 2, but it's a constant, same concept as this 3. Like I really don't have to worry about the constants right away. I really just want to make sure that my derivative of my u will substitute out the rest of my variables. Now, let's just pretend you're like, you know what, why not set u equal to x squared? Look what happens when I set my u equal to x squared. I get du, so the derivative of x squared is 2x. That doesn't help me. That doesn't substitute out this, and then I still have this to the 6th. Like that's not helping anything. So that is not going to be a good u. And the more you do u substitution, the clearer it gets, and where that instinct starts to kick in, like that math instinct of like, all right, here's what I'm gonna use as my u, because I'm seeing a couple steps ahead, that I think the derivative is going to be able to knock out a couple things here, and that's what we want. We want to be able to substitute everything else out. So now, how do we deal with these constants, though? What you could do is you could rewrite this as 2 times the integral of x squared times x to the third minus 5 raised to the 6th, and just showing you what the process here. So if I have x squared dx, I can divide by 3. So what I end up with is x squared dx equals du over 3. So this and this, x squared dx, is going to substitute out for du over 3. So I'm going to rewrite this as 2/3. I'm going to take out that 1/3 times the integral. And then I'm going to substitute x to the third minus 5 for u. See, that's the whole reason why I set u, because this whole term now is going to become u. So it's going to be u to the 6th du. This step to this step is the crucial, most important step, making sure you're doing that substitution correctly. And I know this divide by 3 is probably where you might have the most, like, wait, how is that working? And that's not where you should be focusing your attention on right now. You want to make sure you're doing this correctly, and then worry about those constants. And the constants, you really don't have to put a whole lot of thought into it. I just took the 2 out. You don't even have to. And if this constant's a 2 and we get 3x squared, just divide by that term, and then it will just offset it anyway. And sometimes like they'll be able to cancel out, or sometimes you won't even need to divide. Like it'll just kind of work out, and it just by a case basis, you just have to play around with it a little bit. So in this one though, I got 3x squared dx, so I divide by 3, leaving me with just x squared dx, and then du over 3. So I could have just left this as du over 3 on the inside, but I just took out the constants. So like this was over 3, took it out, so I wrote it as 2/3. Now it's just a integral, normal integral, and no, it's not in terms of x, it's just u. So this is going to be 2/3 times u to the 7th over 7. This is plus 1. 6 plus 1. And then from here, this is not our answer. You want to make sure you're doing two things. You're putting back the u, whatever you set u equal to, and then you want to make sure you multiply it 3 times 7 here on the bottom. So I'm going to go right here. So I'm going to have 2 times my u is x to the 3rd minus 5 raised to the 7th over, and then 7 times 3 is 21. Substitution is one of the more difficult concepts to wrap your head around right away. It's definitely a topic that you're going to need to practice and just keep doing problem after problem after problem, and just to look at different scenarios, because substitution is different almost every single time. Like sometimes we won't have these constants to worry about. Sometimes we have to do a little bit more manipulation to make it work. It's really a case-by-case scenario with substitution. But and then one other thing you want to just double check, make sure that this doesn't actually simplify, like 2 over 21. This doesn't. But what if it was like 2 over 20? Then we could have simplified that. But in this case, it's not, so just something to keep in mind that you always want to make sure you're simplifying. But everything else here looks pretty good.